This is your tiered treasure hunt. You should have received this worksheet based on how quickly you completed your activity in class. I'm going to solve some of these problems, but just set up others. You can also see the setups in the answer key, but I figured explaining some of the setups might help jog your memory just a little extra. Our first problem here is asking for the value of x. We need to look at our angles and determine which of the four angle relationships exists. Now, this is why memorizing your vocabulary is so important. We've talked about complementary angles, we've talked about supplementary angles, we've talked about vertical angles, and we've talked about adjacent angles. Here we have a pair of supplementary angles, and we know that they're supplementary because together the two angles form a straight line. And any straight line adds up to 180 degrees, so these two angles together are going to equal 180 degrees. So we want to set up our algebraic expression, 5x plus 100, because those are the values of each angle that we have already stated add up to 180 degrees. Now this is a simple two-step equation. You should be able to rely back on your experience from 6th grade as to how to solve a two-step equation. First, you subtract 100 from both sides, then you'll divide your remaining solution by 5, and you'll get a value of x. Up here to the right, we have angles on opposite sides of intersecting lines. And since they are on opposite sides of intersecting lines, we call those vertical angles. And based on what we recall in class of vertical angles are congruent, which is a fancy math term that means equals. So anytime we see vertical angles, we should first be thinking equal. So I have 136 on one side of the angle. I have 11y plus 15 on the other side of the angle. Because these two angles are equal, we can set up an equation that states that they are also equal. Now again, we're down to a two-step equation where we will subtract 15 from both sides and divide the remainder by 11. Third problem, our definition. Well, let's look. We have a right angle signified by the little box in the angle. You should be used to that from your definitions of right triangles. And so we should be thinking right away, as soon as we see a right angle, something is going to add up to 90 degrees, because that's generally what happens when you see a right angle. Now here we have two angles that add up to 90 degrees, so the two angles together are going to form this one big angle that's 90 degrees. We call that a complementary relationship, so we have complementary angles. So I need my expression on the left side of the equal sign, 6x, which is the measure of the one angle, plus 4x, which is the measure of the second angle, both add up to 90. Now again, this is simple 6th grade math. We combine like terms. 6x plus 4x is 10x. And then we divide both sides by 10. Now that we get to the top, it's going to start to get just a bit more complicated because we have to sit there and say, what information do I need to solve the problem? We're solving for both x and y. Now, in all of our practices with one and two-step equations, we've only been dealing with one variable. It won't be until later this year that we'll really start dealing with more than one variable in the same problem, talking about independent, dependent variables, input-output relationships, what constitutes a function. All of that will come in later in this year. Right now, we're going to deal with one variable at a time. So we want to set up an equation that utilizes one variable and some other piece of information sitting within this image that's going to help us solve for the value of that variable. got lots of options. I've told you when we're putting together our puzzle, it's easiest to look for the exterior or the straight pieces that go around a puzzle. And when you're dealing with angles, I think the first thing to always look for is vertical angles. Vertical angles are always across from each other on intersecting lines, and so we see them right here. Vertical angles. Those two angles are equal to each other. So I can very easily say that 48 is equal to 1.5y. And if we divide both sides by 1.5, then we're going to end up with a value of y that equals 32. Now that's only half of the problem. We know that the value of y is 32 degrees. Now there are a lot of different mathematical ways to solve for the value of x. On one hand, we know that this angle here is 48 degrees. So this angle over here that has nothing in it must be 132 degrees. So if we really wanted to, we could set up another vertical angles relationship, 8x equals 132. That would definitely work. That's one option. Option number 2, which I'm going to go ahead and model here, we again see a straight line. And since there's a straight line, we see a supplementary relationship, where the 8x angle plus the 48 angle is going to equal 180 degrees. Now, the reason why I didn't solve out the previous process with the 8x equals 32 is because I wanted to model a secondary process, but also show you how they relate to each other. So if I subtract 48 from both sides, we're going to cancel out the 48. They simplify out, and we're left with 8x equals 132. So despite the fact that we did not set up a vertical angle relationship, we set up a supplementary relationship, we still are going to end up simplifying to where we see that 8x is equal to 132. At which point we will divide by 8, and x will be equal to 16.5. I'm going to let you at least give the last one a chance. If you need more help with it, you can look at the answer key to see what's going on with that particular problem. Right now I want to look at this top right-hand problem here. This top right-hand problem tells us that the measure of LTU, which is this angle here, is 4 times greater than ETU, which poses a problem because we can't solve for the measure of the one angle, which is 4 times greater than the measure of the smaller angle, unless we know the measure of the smaller angle. Therein lies our problem. We don't know the measure of the smaller angle. So one of the things you will find in algebra is often, when you don't know the measure of an angle, you need to substitute in your variable. That's our unknown. That angle itself is the unknown. Now we do know something about the relationship between this angle, ETU, and the bigger angle, LTU. We know that the bigger angle, LTU, is 4 times whatever that size is. And we can represent that with an expression for x. Well, now that we have our angles measured with variables, we can go continue to look at the rest of the problem. LTE is 70 degrees. Well, it's not 90. It's not 180. And they're definitely not two intersecting lines with opposite angles for them to be vertical angles, which leaves our only remaining classification, which was adjacent angles. And we've talked about in class that adjacent angles are two angles, something plus something else, that are going to equal a given value. In this case, the given value is 70 degrees. Well, now we can set up the rest of the equation. This angle, LTU, which is represented as 4x degrees, plus this angle, ETU, which is represented as x degrees, together add up to the given value of the larger LTE angle of 70 degrees. So we're going to combine our like terms. 5x equals 70, where x will then equal 14. Now, we've also been warned to pay very close attention in class to what the question is asking for, because I noticed several students were stopping at x equals 14, circling that as the answer and saying, hey, I'm done. There's a very common trend to say, I found the value of the variable so I can finish the problem. No, we have to be very careful to make sure that we are answering what the problem's asking for. This particular problem is asking for the measure in value of LTU. LTU. Now, LTU is 4 times the value of x, so we need to take that value of x and plug it in. So 4 times 14 gives us an angle that is 56 degrees. Now, when you're writing your answer, what I would like to see, the measure of angle LTU is equal to 56 degrees. You should have one big box that looks like that. Now, hopefully that should be enough information to at least help you think through the remainder of the problems. Again, you only had to complete one of the 3 sheets. I encourage you to have more practice rather than less, so if you have time to practice the other remaining sheets, that might be advantageous in preparing for the upcoming quiz. Have a good day.